This is Britt Caswell with another example video. In today's video, I'm covering example 1 from section 9-2 in the SavvasRealize Algebra 1 textbook. The goal of today's video is to use the zero product property. Now, the idea of the zero product property is that if you have two numbers, A and B, that are being multiplied together, if their product is equal to 0, then either A equals 0, B equals 0, or they both equal 0. Right? And so this concept is a very pivotal concept throughout algebra. So if I were to not cover the zero product property here, we would not be able to do pretty much any form of mathematics beyond this. All right? So this is very much a cornerstone in our education with algebra, and very important for you guys to understand. All right, so luckily, the zero product property is also something very easy for us to deal with, so we can kind of, get in it to win it, essentially. So here's how we move from A times B equals 0 to a set of parentheses times a parentheses equal to 0. So if I have an equation that's written out here in what's called factored form, although I think that your book calls it intercept form, I don't remember. Most people call it factored form. So if you have an expression written in factored form, you could take each of the factors, so each of the things being multiplied, and you could set it equal to 0, and that'll tell you your solution. All right, so my first set of parentheses here is x minus 9, so I'm going to set that equal to 0. And my second set of parentheses is 5x plus 2, and we're going to set that equal to 0. All right, so here in the blue, I'm going to add 9 to get x alone, and I get the solution x equals 9. And on the red solution, this one's a two-step equation. So first I have to subtract the 2 to get rid of my addition. And then I need to get rid of this multiplication by dividing by 5. And I'm just going to leave that in the fractional form of negative 2/5. So these are the two places where our parabola will cross on the x-axis. So what I have is I have a graph here, and let's take a look at that. So you can see the first one at 9, and that's definitely the solution we got, the blue solution. And the second one is at negative 0.4. So if I were to convert negative 2/5 into a decimal form, that's where the negative 0.4 comes from. So easy peasy to find those solutions, right? Now here's what's kind of cool. Okay, I'm kind of doing an extension to get you guys to look ahead a little bit. Because the graphs of quadratics are symmetrical, right? This vertex lies on the axis of symmetry. Okay, we can use our zeros that we got to find the axis of symmetry using this formula. X equals P plus Q all over 2. All right, so this is just an average. So if you take the average of these intercepts, you will find the x value for your axis of symmetry, which is also the x value for your vertex, and will start enabling you to get your minimum or maximum. Okay, so that's how you kind of unlock a little bit of additional information as we are moving forward in quadratics, which is cool. All right, so now the triad is asking us to solve each equation. So we're going to solve it using the zero product property, and then I'll reveal the map or the graph so you guys can verify it. All right, so on this first one, I'm going to say 2x minus 1 is equal to 0. And I'm going to say that x plus 3 is equal to 0. Alrighty, so this green expression, first I need to add 1 to get rid of the subtraction. So I get that 2x is equal to 1. And then I'm going to divide both sides by 2 to cancel out the multiplication. And I get that x equals 1/2 or 0.5, either one. On this blue equation, all that I need to do to get x alone is to subtract 3. So I get x equals negative 3. And so these are my two solutions. So this parabola, you can see it right here, is crossing at negative 3, 0, and at 1/2, 0. And halfway between negative 3 and 1/2 is negative 1.25, which I could have gotten from this formula. All right, let's try one more time. So again, I'm taking each thing that's being multiplied and setting it equal to 0. So the 2x plus 3 is equal to 0. And the 3x minus 1 is set equal to 0. So now solving out the red, okay? I got to get rid of the addition before the multiplication, so I'm going to subtract by 3. And I get 2x equals negative 3. And then to undo this multiplication, I divide both sides by 2 and get x equals negative 3/2. That's the same thing as negative 1.5, if that helps. All right, now here with the green, I'm doing kind of that same procedure. I got to get rid of the subtraction by adding. So I get 3x is equal to 1. And then to cancel out that multiplication, I divide it by 3. Now notice this method is a lot better than dealing with that table method from our last section, right? Because tables of values don't always have 1/3 and negative 1.5 on them. And so factoring it out and then setting each factor equal to 0 will get you these kind of quirky answers that tables wouldn't otherwise give you. And so you could see those intercepts right there. So that is how to use the zero product property. Until next time.